Good morning, everyone. Happy Friday. Right. So Miss Minion will not be able to join today. So if you're writing something in the chat, you will not get the answer back in the chat, but feel free to ask me after the class if you have any specific questions. Anyone has any questions to me before we start the class? About the chapter that we started last class or anything else? All right. If not, let me just quickly review what we did in the last class, and then we will finish our last topic, which is 3.2. Your homework assignment and quizzes are open. The due date was 28 before, but I extended. We will be able to finish everything today. So feel free to start working on your homework assignment, but I extended it for a couple of days so that you will understand that chapter well before attempting the quiz. So last time we talked about, in chapter 3, we are talking about how do we produce data and what are the good ways of producing the data and what are the bad ways, or you can say, in other words, what are the things we need to be careful when we are producing the data. And how we are producing doing the sampling. And we learned in the last class what are the good sampling methods or what are the different sampling ways. So we learn about different sampling ways, and once we know which sampling method we are working with, first we follow that and then do the simple random sampling from that using that method. So last time we talked about simple random sampling, and again we use simple random sampling either using table B or calculator, or write all the names or label label all the subjects, put it in the box, and then take 1 out, 2, 3, 4, how many you want in the sample, or using technology. And Excel is the easiest one to do your random sample. So if you mention you are looking from a population of 1,000 and you are picking a sample of size 10, you can do using this the fast way. This you can do take longer time. This you can do it fast way because you need to just specify between how many numbers you need 10 sample, and this will take longer way. But if you are working with a smaller sample, you can use this, this, or this, or this, or anything. Again, when we all want the same sample from the same population, we use table B, or you can say table B also the same line. So if we all are looking for the same sample coming out from the same population, then we are using table B and using the same line in the table B. Let's say if I'm using 120, line number 120, we all are using 120, and then we all get the same sample. Again, first thing, before looking at the line, we need to label them. And how do we label? If we are looking at the same sample to be picked, we need to label first, organize them in alphabetical order, and then label from 1 to 3, depending upon you organizing rows or columns. And then if you are working with one digit, let's say our last digit is 5, 6, 7, 8. Then when you do the partition after every one digit. Let's say this is my line. And if I will do that partition after every one digit and see if this is in my population, if this, and then I can take accordingly. But if I'm working with 2 digits, let's say I have 15, and out of 15 I need to pick 2. I need to label everything with 2 digits by adding a 0 in front, and then I can do. So when you do simple random sampling, again, there are different methods that you can use to do it. Once you understand what simple random sampling is, the second thing we learn is stratified sampling. And stratified talks about stratas or groups. So first make the groups that have something similar, and then do the simple random sampling from each group. So depending upon how many groups you have, and then groups are given to you. So groups are known that are similar in some way. That's how you will make the groups. And then from groups, you do simple random sampling. Third one, we talk about multi-stage. So in stratified, we say 2 stages. One is you make group, and then you do simple random sampling from there. When we say multi-stage, so that means you're talking about more than 2 groups, more than 2 stages. So you are making groups, subgroups, and then do the simple random sampling from there. Or you can do the same thing and then do subgroups, and then do simple random sampling, depending upon what information we have. The fourth one, we talk about systematic sampling. So when we say systematic, we set up some kind of system before doing the random sampling. And the system is first find your K, and K is your population over what your sample is. And once you get that K value, and we use the example, we had 28 hotels and we were looking at the sample of size 4. So my K came out to be 7. Then I laid out these 7 observations or 7 subjects, and then use my simple random sampling, either using the calculator, table, Excel, or put them in the box and pick one number. And let's say it's this. So that will be my first sample, and every 7th after that will be my next sample. And then these are your respective labels for the samples. So this is what we learned in the last class about the sampling. And then we also learned what are the good and bad ways of sampling. So these are the good ways of sampling, and the bad or the that you need to be careful about when you do the sampling. You should not do convenience sampling. Convenience sampling brings bias to your sample because you are not doing randomization. You are not giving every single subject an equal chance. Again, when we talk about cautions, we need to see if there is an undercoverage. When you select the sample, are you missing some part of the population that should be in your sample or not? So take care of that. Non-response. So you select the subjects in your sample, but those samples, either they are not contacted, not the right word. They are not responding when you try to contact them. Either, let's say, either their phone number is changed or their address is changed. So you collect the sample using simple random sampling, but you are not able to contact the subject when you are doing the survey. So you start with, let's say, 100, but now you got only 80 responses. So again, your sample will suffer from non-response because you need a sample of size 100 for that particular population to do the inferences. But now you have only 80 respondents. So basically, your sample will suffer from non-response. We also talk about voluntary response bias. So people with strong opinion, and sometimes they give their opinion, and the people who does not have strong opinion, they do not even try to give their opinion, or they do not do any effort because they know that strong opinionated people will respond. So that will also suffer from bias. Question wording. So if you have the wording of the question is confusing or not appropriate or not in the right order, the subject may not the subject may not feel comfortable responding back to the question. So question wording or question bias, you can say wording of the question, order of the question, meaning of the question, so everything. And then sometimes we also called in interviewer influence bias. And again, if somebody is interviewing you and you don't feel comfortable giving the answers, maybe you don't like that person, or maybe some history or something that you don't feel comfortable asking or comfortable giving the answer, you might not give the correct answers. And same thing if you like the interviewer, or if that is your favorite anchor or a favorite news reader and you feel comfortable asking all the questions. So maybe some of the questions, the answer is no, you know from inside, but because you know that that person will feel or that person will like it, you may end up answering something else. So these are the things we need to be careful when we talk about sampling. So our next or the last topic for this chapter is designs of experiment. What do? We talk about what is an experiment. When our goal is to see if there is a cause and effect relationship, we work with experiment. And what do we do in the experiment? We apply the treatment to the subject, and then we see if there is a cause and effect relationship or not. So there are some fundamental things about when we talk about experiment. What is an experimental unit? Subject, treatment. So when we are talking about subjects, subjects are the experimental units. When we say those are human or animal, we call them subject. So if I take a sample of size 5 from your class of size 45, I am collecting a sample of 5 subjects. And then experimental units not necessarily can be human or animal. They can be anything else, non-human also, maybe fabric or the glass piece or the books or anything that you can. But when these experimental units are human or animal or live, we call them subjects. And treatment are what we are applying to those experimental units to see what is my result, or what do you say, what is an cause and effect relationship. So you can say that it is an experimental condition applied to the experimental units. So treatment is the experimental condition that is applied to the experimental units. Let's say we want to see, let's say I'm baking a cake and I want to see how fast it will bake when the temperature is 150 degrees, how much time it will take for 200, for 250, for 300. So these are the treatments that I am applying to check what happened, or 400 or 450, how much time it will take to bake. And again, then I can check other things. If I'm using an hour to bake the cake, which one is the best out of this? Or which one get burned, or which one is not fully baked? So the experimental condition that I'm applying to that experimental unit, I'm talking about treatments. We will talk about comparative experiments. Randomization we already discussed in 3.3 when we are talking about simple random sampling. We discuss about what randomization is and what are the ways we need to do to prevent bias in our sample. The first thing we say that randomization is the key to prevent bias. We will talk about principle of experimental designs. There are 3 basic principles that we use when we work with the experimental design. Again, when we work with the experimentation, what are the things we need to be careful of? We also talk about match pair design and block design, and these 2 are your experimental design. So we will talk about experimental design. And match pair design, we will just talk a little bit here, but in chapter 6 and 7, we will talk about match pair in detail with the data set. So these are the definitions. Any questions for me? If not, an experiment in a study is a study in which we actually do something, apply treatment to people or animal or objects, the experimental unit to observe the response. And these are the definitions that we just discussed. And note one more thing, factors. Factor is another name for explanatory variable. So in chapter 1, we talk about explanatory. In chapter 2, we talk about explanatory and response variable. And we also said that this is independent and this is dependent variable. And then you can add another word to your vocabulary. We also call that as factors. So if we are talking about factors, we are talking about explanatory variable. If there are two factors, that means I'm talking about two explanatory variables, three explanatory variables. A specific condition applied to the individual in an experiment is called the treatment. A treatment has several explanatory variables. A treatment is a combination of specific values of these variables. If a treatment has several explanatory variables, so if you have more factors and you are looking for a treatment, it is a combination of all or specific value of these variables. So you're looking for how many are we are talking about. Now, need for comparative experiment. So now we are going to talk about what is comparative experiment. Before talking about this, let me just talk about principles for experimental design. So when we work with the experimental design, we look for three things. And these three things are very important because they help us to understand why we are doing experimental design. First of all, like how we discussed in chapter 2, we see confounding variables. And again, what is confounding variable? When you are looking for confounding variables are also called as your mixed variables. And lurking variables are called as your hidden variables, right? So if I'm talking about an x and y, this is my explanatory variable and this is my response variable. When I look at my response variable, I am unable to differentiate if this response is just because of x or is it because of another variable, and that another variable is hidden, so I can call it as lurking variable. So when I see a mixed response on y, it can be either because of x or because of my other x, let's say x1 and that's x2, the lurking variable that is not in the picture, but it's still affecting my response variable, then I'm talking about confounding variable. When you see the mixed effect. So when we are working with the confounding variables, and we say that in chapter 2 that how to control the effect of confounding variable. The good thing is you can control the effect of confounding variable. Like how? Control the effect of lurking variable. Control the effect of lurking variable. And how do you control? On the response by comparing two or more treatments. And we will do an example and then it will make sense by comparing two or more treatment. And then here we just talk about comparative experiment. So this comparative experiment comes from here. We are comparing the experiments. And how do we compare? We apply different treatments to different groups, and then we compare the effect in each group and see if this is effective in first group or it is defective in the second group, third group, depending upon how many treatment we are working with. So comparison, two or more treatment, depending upon how many treatment we have. Comparison, treatment and comparison, they both help us to control the effect of your lurking variable on response variable, and that will help us not to have confounding. Number 2, again, actually this should be number 1, or let me write randomize. So first thing you need to randomize. Randomization is always important. So again, use chance to assign subjects to treatment. And when we are saying use chance to assign subjects to treatment, so we are doing simple random sampling. But this simple random sampling will be done before we assign the treatment to that. So we are doing the same thing what we did in 3.3, but little bit further work depending upon how many treatment we are working with. We need to make that many groups and then us do the simple random sampling from there. And when we do example, it will make more sense. And the third, or the most important one, we call it repetition. Or another word, you can say enough subject. So you should have enough subjects. When we are working with applying the treatments to who? We are applying the treatments to subjects. So we should have enough subject in each group to reduce chance of variations in the results. So we should have enough subject when you are applying the treatment. So if you do not have enough subject in each group, then you may not be able to apply the treatment and compare. So these are called your 3 basic principles of experimental design. And again, they are important because we follow all these 3 experimental design principles when we do the actual experimental design. And then you can write a note to yourself: randomization, which is your second point, and comparison, which is your first one, together prevent bias or systematic favoritism. Bias, which is we call systematic favoritism. Again, randomization and comparison together, they will prevent your bias in your design or in your sample when you collect the sample. So randomization, again, we said that randomization is a key to prevent the bias. And when we're doing the experiment, comparison help us to eliminate the effect of your lurking variable. So that means randomization and compare all together helps you to prevent the bias in your experimental design. And you will find this information in your slide also somewhere. Somewhere it's in the slide, so I will come back to this. So now what is comparative or we can say what is the need for comparative experiment? How does comparative experiment help us? So as the word says, comparative experiment, so that means we are doing an experiment where we are comparing things. And when we are comparing things, what are the things we are comparing? So when we are saying comparative experiment, let's read this example first, and then we will talk about that. Experiments are the preferred method for examining the effect of one variable on another. By imposing the specific treatment of interest on control and controlling other influences, we can pin down cause and effect. And how do we control the influence of other variables? Again, by randomization and comparing. So again, comparative experiments are important because we can control the effect when we compare those. And here is an example given, and let's quickly read this example and see if this example is talking about comparative experiment. Is it a good example of experimental design? Is it a bad, or what is missing, or is it perfect? Let's read. A study designed to reduce test anxiety had students write an essay about their feeling concerning an upcoming exam. Students, they write about their feeling and then they observe their exam scores. The score in this exam, which is your second exam, were compared with those in the first exam. The mean score of the second exam was higher than the mean score of first exam. So what did this study do? The student write the essay about their feeling, and on the basis of that, they observed the exam scores, and they found out that exam 2 scores are better than exam 1 score. And now the question is this writing exercise effective? If yes or no, how can you tell? Are you certain the increase is due to the writing exercise? Can we do the same for our test too? You all can write an essay about your anxiety about your test too, and then do nothing about your chapter 3 and chapter 4 concept and just take the test and your test score is higher. Will that be possible? Okay, so again, when we are talking about this experiment is poorly done because we are not doing any comparison here. And again, writing exercise is alone is not effective, because if we are just writing, not studying, it's not going to help us pass the test or get the better mean score for test 2. So this test anxiety experiment was poorly designed to evaluate the effect of writing exercise. First thing, lack of comparison group is one problem with it. And the second is placebo effect. And if you are in biology side or environmental side, you use this word placebo effect a lot of time. And this is nothing. It is the effect of a dummy treatment. So we use something very similar that we are using for actual treatment, and the subjects cannot find if they are getting the treatment or they are getting the placebo. Placebo is exactly like the actual treatment, but it is not a treatment. It is a effect of a dummy treatment. So when we talk about the study on the previous slide about the writing exercise, that is poorly designed, because there we are not even talking about comparison and we are not even talking about placebo effect. So placebo effect occurs when people respond favorably to personal attention or to any treatment they hope that will help. In comparative experiment, subjects are assigned to one of two or more groups. In many studies, two such groups are control group and treatment group. So when you do your comparative, and again, the word comparative tells us that we are doing comparisons. So when we do comparative experiment, we work with two groups. One group is called your control group, and another called is your treatment group. And again, when we are talking about control group, we are talking about dummy treatment, and treatment group is actually getting the treatment. And when we talk about placebo effect, the subjects who are getting the treatment and the placebo, they do not know if they are getting the treatment or the placebo, because if they know they are getting placebo, they will react differently. So if they know that I don't know if I'm getting treatment or placebo, I'm getting the same thing, then I will react that way. But if I know this is a fake treatment, this is a dummy treatment, I will react like that. So when the subjects does not know they are getting the treatment or they are getting the placebo effect, they work that way. Sometimes the researcher or the people who come in contact with the subjects, they also don't know who is getting the treatment and who is getting the placebo. Then that experiments are called double blind experiment. Double blind experiment. So let's say I'm working with I'm doing some study, and I provided the placebo and treatment to the hospital, and it's like you can apply these to all the subjects or all the patients that you have. So they don't know they are doing the placebo, or they are giving the placebo or the treatment to the subjects, but I do know. So if the researchers or if the person who is in contact with the subjects, they don't know if they are giving the placebo or the treatment to the subjects, then that experiment is called double blind experiment. And then placebo, you can think of that as a single blind experiment, because the subjects do not know. But the people who are in contact with them, they know who is getting the treatment and who is getting the placebo. A study is biased if it systematically favors certain outcomes. And again, our whole goal is to not have bias in our sample. Need for randomization. Again, we discuss it. So I'm just moving this slide. I'm just passing it. And before that, let me just write here. randomized. And you can check with the slide what I am doing it here because we do not have much time. So I will explain here. So when I'm saying the randomized comparative experiment, to read the word randomized comparative experiment. So I'm doing the randomization, I'm doing the chance process, and then I'm doing the comparison. And then experiment, that means I'm applying the treatment. So randomized comparative experiment are the best ways to eliminate the bias and give us good results because we are doing the chance process, giving equal chance to every subject, then doing the comparison, applying the treatment either to different groups or applying the treatment and the placebo and then comparing. And again, treatment is there. So when we talk about randomized comparative experiment, we are talking about the chance process to get the sample and that will be applied to, and the treatment will be applied to that sample and then we compare the results. So first one is your completely randomized design. When we are talking about completely randomized design, we can also write it as CRD, randomized comparative, or CE, and then here CRD. When we are talking about completely randomized design, all subjects are allocated at random to all the treatment. All subjects allocated randomly to all treatment. Let's say I have 4 treatments and I have 45 subjects. Let's say 40 in order to, okay, let's take 45. And I have 45 subjects. So I am applying 4 treatments and your class, I have 45 subjects. So I'm applying 4 treatment to all of my students in 27101. So when I have 45 subjects, I need to apply treatment for treatment. One way is like, okay, first 10, I'll apply first treatment, second, third, fourth, fifth. So first group, first 11, I'll apply for first treatment. Next 11, I apply second treatment, 11 third, and then 12 fourth. But is this called randomization? Will that call randomization? Anyone?
No.
No. So this is not called randomization. This is my convenience sampling, right? I said, okay, first 11 go to this group, this treatment, this. So again, this is not correct. What I do the same way how I did for simple random sampling. So I have 4 treatments. So first I need to make 4 groups with this 45 students. And how do I make these groups? I will do my simple random sampling. So I will either use my table B, or I will put them in the box, or I'll use calculator or generator, random generator, and then I will start. My first subject will go here. Let's say it's 3. Next is 1, then 5, then 7, and keep on doing until I get this 41 distributed. So this one, since I start with this, not necessary I need to start with group 1. I can start with group 2, group 3, group 4, because you are doing randomization. So you can start from any group. Once you are done, so let's say I started with group 1. So group 1 has 12, and then rest of them has 11. So they are kind of evenly distributed, except since I have 45, so I have 1 more. And whichever group I start with, I have 12. If I started with 4, it has this. Now, when I assign the subject evenly here, doing simple randomization, I eliminate the chances of bias. Because I don't know who is in this group, who is in this group, who is in this group. And let's say I make 4 tests, and I want to see which test or which group did better, or which test is better or easier, or where student get higher score. So I make test 1, test 2, test 3, and test 4. And then I will compare their results. So this is called your completely randomized design. So you allocate all the subjects evenly in all the groups using simple random sampling. So that's why I want to explain simple random sampling or 3.3 first, because that's what you use here. So you get these 12 or 11, 11, 11 using simple random sampling. And again, you can randomize your treatment. I give treatment first to this group. You can give treatment first to this group, 3 here, or maybe 1 here, or for whichever way, because you are doing randomization. So you can first make the groups using randomization, and then you can also randomize the treatment, or you can just use the treatment the same way because you already randomized here. And then you compare the results. And that is called your completely randomized design. Questions? If not, the next one is randomized block design. So when we say completely randomized design, think of that as simple random sampling. You did a fair, simple way. You did simple random sampling, then apply the treatment and compare. When we talk about block design, block is again, you're talking about groups. So think of that as stratified sampling. In sampling, we were just doing the sampling, but in experiment, we are doing the sampling, assign the treatment, and then comparing. We are doing further more than what we did in sampling. So extra step, what we are doing the sampling, then applying the treatment, because we are talking about experimental design. And experimental design, you do the treatment, and then you compare. When you talk about block design, again, blocks or groups are known to you ahead of time. So let's say if I'm talking about 45 students and I'm making blocks, how many of them are freshmen? How many of them are sophomores? How many of them are juniors? And how many of them are seniors? So if I look at their registration stuff, I know that how many of them are freshmen, how many of them are so I'm not doing random sampling here. This information is given to me. I know how many of them are freshmen, let's say 18, 12, and then you keep on going depending upon how much, maybe less senior, less junior, whatever. That information is given to me. So I have not done anything here. What I know the groups ahead of time. Now, once I know the groups, I am going to, if I know how many treatments are applying, let's say I'm working with 3 treatments. And I have 4 groups. Now I am giving these treatments to each group. So if I'm giving 3 treatments, now in completely randomized design, you give treatment to each group here, 1 treatment. But when we talk about block design, we give all the treatments to each block. So when I'm talking about this, I am going to make 1, 2, 3 groups here. Group 1, group 2, group 3. And how do I make these groups? Again, I'm doing simple random sampling. So this information I know ahead of time, but this work I have done. The same I did in completely randomized design. And then I apply treatment 1, treatment 2, treatment 3, and then I compare within each block. So that is called your randomized block design. Same thing you do for other one, 1, 2, 3, you make 3 groups and apply treatment and compare. Same thing for this and this. So now you are applying 3 treatments within each block and comparing within each block. So that is your randomized block design. And
could
you
go back to the randomized design, the first one, and show how you did?
Can you say it a little louder? I can't hear you. I'm sorry.
Could you go back to the first one, the completely randomized design?
This one?
Yes.
Yes, tell me.
Thank you.
So completely randomized design, we don't have the groups. We have only the treatments. So we know that we have 4 treatments. So we do the randomization, or you can say that we do simple random sampling and make 4 groups, and then applying the treatment for each group. But when we talk about the block design, we know the blocks ahead of time, and then we do randomization within each block, and then apply treatment within each block, and then compare. Does that make sense now? Questions? Okay, the last one is your matched pair. And again, as I said that here we are just talking a little bit about matched pair design, but we are doing more work on this in later chapters. When we are talking about matched pair, first thing, what does pair means? Two, right? So when we are talking about match pair, what are we talking about? We are talking about only two treatments. When we are applying only two treatments, or you can say when we are working with a pair, and that pair has two subjects, each subject will get one treatment, and then we compare within each pair. So depending how many pairs we have, let's say we have 20 subjects. And again, when we say match pair, you make a pair as closely as possible. And you can say that twins or something very similar. And in real world, or you can say in real situation, it is very hard to find a pair which is matching as closely as possible. But again, when we are talking about match pair, it is also a common form of blocking. But here we just work with two treatments. So when we are saying pair, a pair has two subjects and two subjects. Each subject will get one treatment and you compare within the pair. This is, let's say, for 20 subject, I have 10 pairs. So each pair will get two treatment and then you compare within each pair. Let's say if I have only 19 subjects. If I have 19 subjects, I have complete 9 pairs, but one pair is alone. So one pair has only one subject, but I need to give two treatment. And since I have only one subject, I randomize the order of the treatment, and this subject will receive both treatment. It depends if it gets first, the second treatment, or the first treatment. So this subject, even though this pair is not complete, but since we are giving two treatment, this subject will get both treatment. You randomize the order of the treatment and then compare. So again, match pair treatment or match pair design talks about only two treatment. But when we say two treatments, if we are working with the design and there it has two treatment, that does not mean that it is only match pair. It not necessary it is match pair. It can be randomized block design. It can be completely randomized design. Match pair work with two treatment, but two treatment can be anything. It can be match pair, it can be randomized block, or it can be completely randomized experiment. And let me see what else we have. So here is the example for randomized comparative experiment. You have two groups, you have two treatment, compare, and I use 4. How to randomize, this is what we did using the box and label all the names. We did that in simple random sampling. Principle, we talk about the 3 principles of experimental design. You can write repetition or application. It's the same thing. Double blind experiment, I also mentioned. So one more thing, the most serious potential weakness of experiment is lack of realism. So you are doing the experiment, but the subjects of the treatment or setting of an experiment may not realistically duplicate the condition that we really want to study. So that brings lack of realism, and that our experimental design may not be very accurate at that time. The random comparative experiment, because it is the ability to give convincing evidence of causation, is one of the most important idea in statistics. And again, it says that evidence of causation. Why? Because we are applying the treatment to see if there is a cause and effect relationship or not. Because we are applying the treatment and then we are comparing within each group, depending upon what kind of experimental design we are doing, completely randomized block, or match pair. Match pair design, we discuss. Block design, also we discuss. Control what you can, block what you cannot control, and randomize to create comparable groups. So this is what we do in experimental design. Control what we can control. If we cannot control, then we can block, make the groups, and then randomize to create comparable groups. So this ends 3.2. And let me see, I think I kind of covered everything. But let me just quickly see. So there is one more definition. You can write it down or you will find it in the slide. Statistical significant. And we will talk about this statistical significant in chapter 6 and 7 using different tests. Significant. What is statistical significant means? So when we are saying statistical significant, again, something related to statistical evidences. So it says that an observed effect is so large that it would rarely occur by chance. Then we call it statistical significant. And again, we do hypothesis testing. We find the p-value, and then we will see what is statistical significant or how do we find a test is statistical significant. So again, we are just talking about the definition here, and we will do a lot of, or you can say we will do everything about statistical significant testing in later chapters. But what actually statistical significant is, when you see an observed effect that is so large that it would rarely occur by chance, because we are giving the chance process, we are using the chance process to select the sample. But if the observed effect is so large that it is not just due to the chance, then we are talking about statistical significant. And as I mentioned, 3.4, we are not testing on that. So make sure that when you get a chance, take a look at 3.4, because 3.4 talks about when you collect the data. What do you do? Or maybe I can start with this topic on our Monday's class. But make sure you take a look at that, because in real world, if you are taking another statistic course and collecting the sample, then you need to be careful about these things. You cannot just start working and going anywhere and it's like, hey, can you participate in my survey? You have to follow certain guidelines. You have to give a written consent form to the subject. You need to approve your study from the board. And then if they suggest some changes, you need to do that. And there are a lot of things that you need to work with before you actually start collecting the data. So I'll stop here. Technically, we are done with chapter 3. You are good to do your homework and quiz. And thank you, everyone. I will see you guys on Monday. Have a nice weekend. Any questions for me? All right. Have a good weekend, everyone.